Hello everyone, this is Dr. Webb. In this video we're just going to do some more examples of related rates problems. What you could do while watching this is, after I go through, I think there's 3 problems and then a practice problem. After each of the 3 problems, you can pause the video and go and work on it on your own, and then you can come back and see how I do the problem. Okay, so here's the first problem. So a stone is dropped into water, creating a circular ripple that radiates outward. If the radius of the ripple is increasing at 2 feet per second, how fast is the area enclosed by the ripple changing when the radius is 10 feet? So this would be a good place to pause it now. Okay, let's start working on this problem. So in this problem, we're given radius of a circle, and the question is about finding the area. So first thing we need to do is get what's the formula that relates the radius of a circle to the area of the circle. And so our formula is area of a circle is pi r squared, where r is the radius. The information that we're given is we're told that the radius is 10 feet, so r is equal to 10, and we're told that the radius is increasing at 2 feet per second. So that's talking about the derivative of radius is 2. Okay, and we want how the area is changing. We want to find area prime. So we have our formula, we've got our information. To get the derivative of area, we just need to take the derivative of both sides here. So left-hand side derivative of area is going to be derivative of area, a prime. On the right-hand side, pi is a constant, so we can leave that out. Then we have r squared, so we should use the power rule on that. So the 2 comes down, we get r, and then we got to remember, like the chain rule, we get derivative of the inside, which is r prime, coming out. Okay, so derivative of area is equal to 2 pi r times r prime. And so 2 pi r is 10, r prime is 2. And so this gives us 40 pi. And this is in feet squared per second. And if you want to know what that is, I will pull out my calculator and get 40 times pi. This is about 125.7 feet squared per second. Okay. So that's how we do this problem. Okay, let's move on to the next problem. The per capita income of an area is equal to the total income of the area divided by the number of people in the area. Suppose a city has 100,000 people and a total income of $6 billion. At what rate is the per capita income of the city changing if the population is increasing by 1,500 people per year and the income is increasing at a rate of $70 million per year? So if you want to work on this on yourself, this is a good time to pause the video. Okay, so going through this, the first sentence gives us our formula for this problem. So the formula says per capita income. I'm going to call that PCI. And it says that it's equal to the total income. Let's call that TI divided by number of people. Let's just let P be the number of people. Okay, and the information that we're given is we're given that the city has 100,000 people. So that's telling me about P, 100,000. Is there any other information about the population? It says the population is increasing by 1,500 people per year. So that's telling me about how much the population's changing. So that's telling me about the derivative. So P prime is 1,500. And then we need the total income. So it says the total income is $6 billion. TI is 6 in billions. And income is increasing at a rate of $70 million per year. Okay, so that's telling me about the derivative of total income. And 70 million, that is 0.07 billion. So both of these are in billion. And this is billion per year. Well, did I misspell billion and million on that? Goes to show you. Okay. So we've got population, we've got total income, we have our formula. We're trying to find the derivative, how the per capita income is changing. So we need to take the derivative of this whole thing. So on the left-hand side, it's just going to be derivative of per capita income. On the right-hand side, this is a quotient, so we're going to have to use the quotient rule. So quotient rule is derivative of the top, TI prime, times the bottom, minus the top, times the derivative of the bottom, divided by bottom squared. Okay. And now we can just plug this information in. So TI prime, 0.07. P is 100,000. Minus TI is 6 billion times P prime, 1,500. And then P squared is going to be 100,000 squared. Okay. And so if we want to plug this in, .07 times 100,000 minus 6 times 1,500 divided by 100,000 squared. And so I get, this is minus 2 times 10 to the minus 7. But what's important here is this is in the units in this one. So the units, this is billions of dollars per person. So $1 billion per person. Okay. And so to turn this into dollars per person, well, there's 10 to the 9th 10 to the ninth dollars in $1 billion. So if I do minus 2 times 10 to the minus 7 times 10 to the ninth, it's going to give me minus $200 per person. And so that's my answer. So the change in per capita income is minus $200 per person. Okay, and so even though both the population and the income, total income is increasing, what this is saying is that the population actually is growing faster than the income is growing, and so that's what's causing the per capita income to be negative. Okay, now let's move to the last problem. Okay, the last problem says 2 cars are driving towards Harrisonburg. The first car is approaching from the east, driving 60 miles an hour. The second is approaching from the south, driving 40 miles per hour. How fast is the distance between the 2 cars decreasing when the first car is 30 miles away and the second is 40 miles away? So I will let you pause here if you want. Okay, let's start working on this. So first let's draw a picture, get a good idea of what's going on. So the first car, there's a great looking car, and it's going this way. Here's Hburg, and so this is car number 1. Car number 2 is coming from the south, and so let's put it this way. And we've got more of like a station wagon SUV sort of thing going on. It's going up this way. And so it's saying, it wants to know how fast is the distance between the 2 cars. So it's talking about that distance there. When the first car is 30 miles away, the second car is 40 miles away, and this one is driving 60 miles per hour, and this one is driving 40 miles per hour. 40 miles away and driving 40 miles per hour. Okay, so first we need a formula. And so we have a nice right triangle going on here. So let's call the top side A, this side B, and then the hypotenuse is the distance between them. We'll call that D. Okay, so the Pythagorean theorem tells me D squared is going to be equal to A squared plus B squared. Okay, the information that we have is car 1 is A is 30 miles away, and it's going 60 miles per hour, but 60 miles per hour, that's decreasing this, and so we're going to put minus 60 because it's getting closer to Harrisonburg. On the other hand, B is 40 miles away, and it's driving 40 miles an hour to Harrisonburg, so it is also decreasing that distance, and so its derivative is minus 40. Okay, and from here we can figure out D, so plugging, we're going to need D in the next step, so let's figure out what D is. So if I plug in 30 squared plus 40 squared, that gives me 900 plus 1600, which is 2,500, and 2,500 is 50 squared. So distance there is 50. Let's erase this stuff out. Okay, so we got what we need. Now let's start taking derivatives. Okay, so we got d squared there. Derivative of d squared, we're going to use the power rule. Get 2d, and then, like the chain rule, we get a d prime coming out of it. D is getting squared, so when we take its derivative, we get 2d coming from the outside of the chain rule times d prime, because that's coming from the inside of the chain rule. Similarly over here, derivative of a squared is going to give me 2a times a prime. B squared is going to give me 2b times b prime. Okay, and we're trying to solve for d prime, so we can plug everything in here. You notice we have 2's all over the place. All of these have 2's, so I can just cancel those all out first. And so d times d prime, so this is 50 d prime is equal to 30 times minus 60 plus 40 times minus 40. And so 30 times 60, that's minus 1,800, plus 40 times 40 is minus 1,600, is all equal to 50d prime. 1,800 minus 1,800 minus 1,600, that is going to be minus 3,400, I believe. Yep. And so to get d prime by itself, divide by 50. I think it's going to give me, let's see, so minus 3,400 divided by 50 gives me minus 68, and so that's in miles per hour. So at this instance, the distance between the two cars is decreasing at minus 68 miles per hour. Okay, now for the practice problem. So we'll talk about this in class on Monday. So the practice problem is a company's production is modeled by the equation P equals 3 times L to the 2/3 times K to the 1/3, where L is the amount of the company spends on labor and K is the amount spent on capital. Currently, the company spends $4 million on labor and $3 million on capital. If the company is increasing their labor expenditures at a rate of $500,000 per year, at what rate should the company change the amount spent on capital if they want production to increase at a rate of $1 million per year? So in this one, you're trying to find the rate of change of K, capital. Okay, and we will talk about this in class on Monday. See you then. Bye.